Okay, so in the last episode we had a look at the equation of a line. Now we're going to look at the distance formula. So we're moving slightly away from actually finding how we can represent a line to actually looking at, well, what is the distance between 2 points on that line? And it can be very useful. If you're looking at cartography, you might be able to graph some streets using linear equations, and then you might be able to find the distance between certain points on that system or that map that you've drawn by using this kind of formula. But there are many other applications as well, so I'll let you explore some of them. I'll just teach you the basics. So, the distance formula is used to determine the shortest distance between 2 points. And if you're familiar with basic trigonometry, you'll be familiar with this. Pythagoras' theorem is used a lot in many different things you do in mathematics, and the distance formula is an example of Pythagoras' theorem again. So obviously, you probably heard c squared equals a squared plus b squared when we're talking about triangles. The same logic is applied. So, again, based on Pythagoras' theorem, and what we do is we have a horizontal and vertical component that are orthogonal. Also, you've probably heard that word perpendicular. It means they meet at 90 degrees, so we can form a 90-degree right-angled triangle in order to do our calculations. And you can see this up here. We have our line, and we have the distance we want to find between A and B. And it's a triangle, it's a right-angled triangle. We've got some change in x, again, that links into what we did with the slope before. All these concepts are related. And then we also have some change in y. And we use these values, the change, the delta y and the delta x, to actually be able to work that out. So the hypotenuse, and you've probably heard that fancy word before, but it is the longest side of a right-angled triangle, and is equal to the sum of the other sides squared. So let's say we had a distance. Let's say this was -1. That point there, A, has an x-coordinate of -1, and this one over here has an x-coordinate of 2. We obviously add -1 plus 2, and we get 3. So that x-length is 3, for example. And then when we have the y, we might have an example of 5 for the y-coordinate at B, and then we might also have A being at y equals 1, for example, so we'd have a length of 4 there is the delta y. And then we would just use that to work out Pythagoras' theorem. It's really that simple. So the shortest distance between the 2 points is the hypotenuse in the triangle. So we know Pythagoras' theorem, and we can work this out. So find the shortest distance between 2 points, 2, 3, and 3, 6. Okay, so what we do is we label our x1s and our x2s because they come in handy, and you've seen me do this in the previous video. So I'm going to set x1 equal to 2, so you can see x1 here, and I'm going to set x2 equal to 3. And then we've got y1, 3, and y2, 6. Just label them there in that neat row. Now what we've actually got is the distance d equals this formula here, and you're probably thinking, well, how did you get that? And there is a very good explanation for how I got that. You know from Pythagoras' theorem that c squared equals a squared plus b squared. But we just want that length c. So what we have in essence is c equals the square root of a squared plus b squared. And that's what we have here. Our a squared is x2 take x1. It's having x2 take x1. It's that difference. And you know difference simply means we're looking at subtraction. So that's how we get that formula. It's just that logic being applied. This is one side, and this is the other side. And it's just a matter of identifying which number is which, and putting them in. So, let's have a look at the next line. 3 take 2 squared, plus 6 take 3 squared. And that's all under the square root sign there. What we can do is we can say, well, 3 take 2 is 1. 1 squared, 1 times 1, it's 1. And then you add on, plus, and we have 6 take 3, it's 3, right? 6 take 3 is 3, we square it, we get 9. Therefore, we have the square root of 1 plus 9, it equals the square root of 10. And that's the distance, that's how far away these 2 points are, again, when these are their coordinates. Square root 10, and of course, we're measuring units. It doesn't say meters or centimeters, but we just say units because it's some arbitrary value that we have, and we may have a scale if we're doing a map, like I originally said. But that's the distance formula, really nice to work with, and thank you very much for watching. Thank you for watching. Join us next time. However, if you need more practice or more support, check out our apps on the App Store. They have great worked examples, they have incredible worksheets and other materials that can help you really ace exams. We have Formulae for iPhone and Formulae for iPad. Also check us out on Twitter and Facebook to keep up to date with all the educational material that's coming out. Thank you.